The last thing I would like to talk about from section 4.5 of your calculus book is substitution with definite integrals. So notice this definition here if you want to read through it. It just tells me that the change of variables for definite integrals. So if I have some inside function u, or g of x, we discussed this in class, and we can either call our inside function g of x or u. If it has a derivative on the closed interval from a to v, and f is continuous on the range of g, then, so if I go from a to b, if I have some inside function, call it g, times the derivative, inside the derivative of f, times the derivative of that inside function. Remember, all it tells us is that it integrates to be a composite function, f of my inside function, where u is just g. This here is telling me that I can change my lower limit and my upper limit to be new limits based on my inside function, based on my g of x or based on my u, depending on how you're thinking of your inside function. The reason this is helpful is because once we come up with our definite integral, we're going to go ahead and use our calculator to help us integrate it from there. However, I will require you to show me that you were able to set up the definite integral before going to your calculator. So if I look at this first example, the first thing I notice is that as it is written, I cannot integrate it. I think that it does not sound very fun to cube this, so I'm going to go ahead and leave that as is and then let my inside, or my u, I'm going to try it as x squared plus 1. Then my du dx becomes 2x, and du just becomes 2x dx. So this worked out very nicely because I can now substitute u in for x squared plus 1. I can substitute du in for 2x dx. But I also, as I was saying up here, I do want to change my limits to correspond with u. So doing that, so if I know that when x equals 0, since that was my lower limit, let's see, if x equals 0, based on this equation right here, when x equals 0, u equals 0 squared plus 1, or 1. That is going to be my new lower limit. When x equals 1, based on my equation right here, my u is going to be 1 squared plus 1, or 2. So that's going to be my new upper limit. So this integral here becomes the integral from 1 to 2, again replacing the 2x dx with du, replacing x squared plus 1 with u, I get u cubed du. From here I'm going to go ahead and go to my calculator. So grabbing my graphing calculator, I'm going to go ahead and I'm going to say math. I'm going to go down to number 9 to integrate. And then remember, I'm going to go ahead and punch in. I know this is a u, but I'm going to use the x variable on my graphing calculator, so I am going to go ahead and say it should look like this. I will write it out for you here. So your screen on your graphing calculator, after you went to math and went to 9, will say something along the lines of function integral. If you have a TI-89, it may look a little bit different. I am using a TI-84. And then I am going to say x cubed 4x with respect to x, so comma x, from 1 to 2, close my parentheses, and go ahead and hit enter. And when I do, I should get a value of approximately 3.75, or actually I get an exact value of 3.75. Then if we look at our second example, I am going to do the same thing. There are only 2 examples, so if you would like to try one on your own without my assistance, this would be a good one to push pause on and go ahead and try. But if you're still not, let's see. So I'm going to go ahead and first go ahead and set my u equal to x cubed plus 1. Then my du dx is just going to become 3x squared. My du is 3x squared then dx. So I notice up here I do have the x squared and I do have the dx. I am missing the 3, so if you remember when we're missing a constant, I can go ahead and put a 1/3 out front. When I put a 1/3 out front, I can add the 3 inside because multiplying 1/3 times 3 is the same thing as multiplying by 1. So I'm going to go ahead and do that and say this is the same as 1/3 times the integral from 0 to 2 of x squared square root x cubed plus 1 dx. Now that I have what I need, in order to substitute du in, I do have, oh, and then I forgot to write the 3. I do apologize. I did put the 1/3 out front, but I did not put the 3 inside. Now that I have the 3x squared and the dx, I can substitute du in. I can also put a u in under my radical here. I do, however, still need to change my limits. So I see that when x is 0, taking my original lower limit, I get a u value of 0 plus 1, giving me u equals 1. When x is 2, using my equation here, I get 2 cubed plus 1. Well, 2 cubed gives me 8, so u equals 9. So now I'm going to go ahead and plug into my integral. So my new integral is now 1/3 times the integral from 1 to 9 of the square root of u du. Now, similar to the last example, once I have this set up, I am going to go ahead and use my graphing calculator. Again, I go to math and then down to number 9, and then I should punch in. It should look something like this on my calculator. I will say the square root of, again, I'm going to go ahead and use x instead of u since my function, or my calculator does have functions in terms of x, comma x from 1 to 9, and that is going to give me about 17.333 rounding to 3 decimals. Notice I have not done anything yet with this 1/3 out front, so I still do need to multiply my final answer by 1/3. So again, I'm going to go ahead and take my calculator and do that. And I do get about 5.778, rounding to 3 decimal places.